All right, for this lesson, we're going to talk about how to find domain restrictions for rational functions. Now, a domain restriction is a value that has to get thrown out of the domain, hence domain restriction, and it happens anytime you have a value that makes your denominator equal to 0. It's not possible to divide by 0 mathematically. It doesn't make sense. So we throw those values out of the domain. So when we start doing this, what you want to do is figure out what does make the domain equal to 0, and then basically say those are my domain restrictions. So let's take a look at part A here. The denominator is right here. Yes, we have a two-part problem. We've got 1 over x plus 3 and a minus 8. The minus 8, because it's not part of the fraction, is not going to be important to us. It's only the denominator. So x plus 3 is the denominator. So what I want you to do is take that x plus 3, purposely set it equal to 0, solve for x like you would normally. X is equal to negative 3. So the domain restriction, and I'm lazy and just write dr, is that x cannot equal, hold on one second because I lost my negative sign, negative 3. Because negative 3 would make this denominator equal to 0, negative 3 plus 3 is 0, 1 divided by 0 is undefined, you can't figure out mathematically undefined minus 8 is still undefined. It doesn't have any meaning. So that's the value that would make our denominator equal to 0. So that first problem is now done. Let's take a look at number B. Let's try again, part B, the second problem. Identify just the denominator. Now the numerator we're going to deal with in a different way, but as far as domain restrictions go, there are no domain restrictions from these problems in the numerator. So take your numerator, purposely set it equal to 0, and solve. So x equals 6. So the domain restriction, again, I just put dr for domain restriction, is x cannot equal 6. That's the only value that causes any kind of problems here for part B. All right, sliding over to part C here. Again, I just want to identify the denominator. Again, the numerator is nice. It's happy. It's a nice little expression. I don't really care. But what I do care about, in my denominator, I have two factors. So what I'm going to do is set each of those factors equal to 0. And I'm going to get, in this case, two values that I need to throw out of the domain. Because in this particular case, each one of them would cause a problem. So let's say x is equal to negative 8. So negative 8 plus 8 is 0. So this 0 is being multiplied times this answer. So it doesn't really matter what this number is. 0 times this is going to cause us concern. Same thing if x was equal to 2, right? 2 plus 8 is 10. I was already doing the math in my head. Whoops, sorry. So 2 plus 8 is 10. Well, that wouldn't be a problem, except 2 minus 2 is 0. So 10 times 0, that turns this whole denominator to 0. So for part C, my domain restrictions are both the values x cannot equal negative 8 or 2. Both of those have to get thrown out of my domain. All right, let's slide on over to part D here. Let's see, denominator, we've got this expression x squared plus 5x. So if I want to solve that, I'm going to take the denominator, purposely set it equal to 0, and solve it. So this one I actually need to factor for myself. So I'm going to take out a GCF of x. And now this is as factored as it can be. So set each factor equal to 0 and solve. Now the first one's done. If I add 5, that second one will be done as well. So my domain restrictions, x cannot equal 0, it's a horrible not equal to, and x cannot equal 5. Either one of these, if I were to put it in the denominator, would cause the denominator to equal 0. Can't have it, so we throw those values out. All right, looks like I've got two more quick examples here. So part E, again, it doesn't matter. I'm going to keep saying this. It doesn't matter what the numerator is. It only matters for domain restrictions what your denominator is. So we're going to take that denominator, set it equal to 0, and solve it. Now, we've been factoring for pretty much the entire year, and that's where a lot of these problems are going to come from, is you're going to need to set it equal to 0, factor it, and solve it. So x minus 7, x plus 2, set each of those factors equal to 0 and solve. So x equals 7 or x equals negative 2. So my domain restrictions, x cannot equal 7 or negative 2. Now, you can have as many domain restrictions as you need to for a problem. Having 2 or 1, you can have a lot of them. Okay, so don't feel like you're limited. So, all right, last problem here, part F. Let's say we're going to take this whole denominator, the whole thing, set it equal to 0, and we're going to factor it and solve it. So first thing I'm going to do is take out the GCF of 2x. So it's going to leave me x squared plus 8x plus 15 equals 0. I'm going to factor this expression further. So we've got 2x, so x plus 5, x plus 3. So 5 times 3 is this 15, and 5 plus 3 is that 8. So I know I've got the right factors. So now I've got each factor equal to 0. And each one of these factors could potentially give me a domain restriction. So the first one here, x equals 0, x equals negative 5, and x equals negative 3. So in this case, I do have 3 domain restrictions. So my domain restrictions, x cannot equal 0, negative 5, or negative 3. The order that you write those does not matter. As long as you list all of them, you're fine. All right, so those are the domain restrictions for this lesson. We're going to have a lot more practice on it when we get into solving rational equations, because we are going to be finding the domain restrictions and solving the problems. So you'll have more practice with this. But of course, if you have any questions or concerns, let me know. The review page will be part of the key for the note sheet.